final example. This time we're going to do some work with EVs, electron volts. And really when I think of electron volts, I think of elementary volts. In other words, the charge is equal to the magnitude of an elementary charge times voltage. Or really, the charge equal to the magnitude of an electron times the voltage. So how much energy does the particle have when it reaches B in EVs? So it's a charge of 2 electrons, 30 EVs is what it's traveling with when it enters through plate A. It's going to cross this battery at the bottom of 20 volts to reach plate B. So plate A, let's take a look at this. Using EVs, it's fairly straightforward. I know the charges of the plates. I've got on the plate between A and B, the long side is positive, the short side is negative. So you can see the long side's on the right. So between A and B, when I look at it, I got to figure out first, will it gain energy or lose energy as it goes across the plates? So B is positive. So it's an electron moving across towards a positive plate. Electrons are negative, so it's going to be attracted. If it's attracted, it's going to gain energy and speed. So therefore, the electron will gain QV amounts of energy between the first plate and lose QV between the second plate. But we'll get a little more into that in a moment. So in 66, the electron starts with 30 EVs. It gains, because it's traveling towards the oppositely charged plate, it gains 2 times 20 volts or 40 EVs of energy. That's the number of charges equal to an electron size times the voltage it crosses. So 2 times 20, that's 40 EVs of energy. So it will have 30 gain 40 equals 70 EVs at plate B. Alright, now let's look at 67. How much energy does the particle have when it reaches plate C in EVs? So at plate B, it has 70. The electron's going to lose energy because plate C is attached to the negative side of the second battery. And between B and C, it's crossing that second battery on the right. So the electron starts with 70. It loses 2 electron charges times EV, or electron size of the charge, times EV. So that's 2 times 10, or 20. So it starts at 70, loses 20. That means it's going to be left with 50 EVs of energy when it reaches plate C.